Okay, good morning everyone. How are you today? I'm fine too. If you are doing well, please type yes in the chat box or give me an emoji reaction. Great, glad to see you all doing well this morning. Before we start, let me quickly check your attendance. Please type your name, presence in the chat box. Alright, I will save the chats for your attendance record. Now, I would like to share screen of my PPT, so please wait for a minute. Can you see my PPT clearly? Good. I will choose the laser pointer. Alright, now welcome back to week 2 of Introduction to Mechanics, Heat and Sound. Last week, we already reviewed the syllabus, assignment, and learning roadmap for this semester. And today, we officially begin our first topic, which is physical quantities and dimensions. By the end of the class, you should be able to distinguish base and derived quantities, identify international standard units, read a vernier caliber correctly, differentiate colors and factors, and analyze an equation using dimensional analysis. Before we dive in, let's warm up together. Please pick up any object around you. For examples, your phone, bottle, pen, eraser, or anything. Have you found it? Good. Now mention the property of the object that you can measure. Alright, good job. You have already mentioned length, area, temperature, mass, diameter, and volume, which are the examples of physical quantities. And do you know, these are our starting points today. Now I want to ask you again, what is the height of the coconut tree? You can make an approximation. For example, 2 or 2 meters. Which one correct? Yeah, the correct one is 2 meter. 2 is a quantity and meter is a unit. As we know that physical quantity is anything that can be measured and expressed with a number and a unit. The other examples of units are seconds, kilograms, and other. Got it? Any questions so far? Not yet? Okay. So now, please look at these figures. What is this? A door. Yeah, you can measure the width of the door using a ruler. Yeah. For example, 1 meter. And this, a bag. You can measure the mass of the bag. For example, 2 kilograms. And this watch. Yeah, you can see, you can measure the time. For example, how long you stay here, and you say 2 hours or 20 minutes, and so on. All right, you already know about physical quantities and units. Do you know quantities are divided into two types? First, base quantities, which are the fundamental ones. Second, derived quantities, which are combinations or of base quantities. Can you mention 7 base quantities? I think in senior high school you already learned about them. Okay, let's remember together. And follow after me. Length, meter, m, mass, kilogram, kg, time, second, s, electric current, m, a, temperature, Kelvin, K, amount of substance, mole, and luminous intensity, candela, CD. Remember, the unit of temperature is not Celsius, although in daily life we use Celsius as a unit of temperature. The international standard unit of temperature is Kelvin. Okay? Okay, now how about derived quantities? Can you mention the examples of derived quantities? Velocity. Good. Velocity is derived quantity. You can see the table. The table shows the examples of derived quantities, such as area, volume, velocity, density, and force. You can see the units of velocity. The unit of velocity is meter per second. It's clear that velocity is come from length, which is displacement, and time, which is the interval, the time interval. Okay, so the unit is meter per second. Got it? Good. Any questions so far? Okay. Now, I want to check your understanding. Please scan this barcode. There are 3 questions. So please finish for 3 minutes. Let's start. Thank you for your participation. Let's discuss the answers. For the first question, what are the base quantities that from the volume? And your answers are length, width, and height. That that's those are correct. But the base quantity is only length because width and height have the same unit and then dimension. Okay? Yeah. And for the second question, what are the base quantities that from velocity? And your answers are length and time. Good job. And the last question, what are the base quantities that from the density? And your answers are mass and length. Good job. We know that the volume has length base quantity. Okay? Okay. We already understood about physical quantities and derived quantities, but how to measure them? Yeah, you can see these 2 figures. The first figure shows us a boy and his dad measuring the width of the table using a ruler. And for the second figure, here there is a boy measuring the width of the table using his hand. So which one will give the good results? The first or the second figure? Yeah, the first figure. The first figure will give more accurate results because they use a ruler to measure the width of the table. So we need standard units to avoid confusion and ensure consistency everywhere in the world. Any questions? Got it? Good. Beside a ruler, there is a tool here, vernier caliper. Yeah, vernier caliper is to measure, used to measure the diameter or the length of an object here, but it is limited by the dimension, so only the small object. We can measure the inner diameter using internal jaws, and we can also measure the outer diameter using external jaws. And then we can also measure the depth of the object using this blade, okay? Okay, now how to read the results of the measurement? Do you know it? Yeah, please pay attention. Here, first, we have to read how many lines before the 0 in the left side. We can count them. 1, 2, 3. So 3 lines, it means 3 millimeters or 0.3 centimeters. And then find the vernier line that perfectly aligns with the main scale line. Yeah, 7. So 7 times 0.1 millimeter. This is the smallest unit of the measurement. And we get 0.7 millimeter. After that, we add these 2 readings and we get 3.7 millimeter. And this is the final results of the measurement. Got it? Any question? Good job. Now you can practice to measure an object using vernier caliper simulation. Please click this link. Let's practice now. I will stop share the PowerPoint and move to the simulation screen. Okay. Can you see the simulation clearly? Good. Now we can measure the length of the cube. Please drag these external jaws and put the cube inside. You can also enlarge this cube like this. And then here. Please read how many lines before 0. 1, 2, 3, 4. It means 4 millimeter or 0.4 centimeter. And then please find the line in the vernier that perfectly aligns with the main scale line. Yeah, we see here 3. So 3 times 0.1 millimeter or times 0.01 centimeter. Here we use centimeter unit, so we get 0.03 centimeter. And then please add these two readings and we got 0.43 centimeter. Got it? Any questions? All right, you can practice by yourself by enlarging this cube like this and then try to measure the length of this cube, okay? All right, let's move back to the PowerPoint and I will stop share. Can you see the PPT again? All right, good. Now, I want to ask you again, is temperature a scalar or a vector? Yeah, scalar. But why? Good, because scalar has magnitude only. You know, we can distinguish scalars and vector. Scalars have magnitude only, for example, speed, time, mass, and temperature. However, vectors have both magnitude and direction. For example, velocity, acceleration, and force. You can see from these figures, there are two cars, but the first car shows speed only. Speed has magnitude only, no direction here. But for the second figure, second car, it has an arrow. It means the direction of the car, okay? So velocity is a vector because it has magnitude and direction. We can also see from the formula. For the speed, there is no arrow here. So d means the total distance and t is the total time. But for the velocity, we can see there is an arrow above the d. D here is the displacement, which is a vector, and t is the time interval. So these two equations are different because scalar and vector are different, okay? Any question? Do you understand? Good. Now let's move to the dimension. We can check if equation is correct or not by dimensional analysis. Here there is a table. The table shows us the three base quantities, right? Length, mass, and time following by the dimension L, M, and T. We can check the dimension of velocity. Yeah, here from the formula, it's clear. It is clear to find the dimension of velocity. L, t power minus 1, right? Okay, how about for the acceleration? Yeah, remember the formula of the acceleration is velocity divided by time interval. So we already knew about the velocity dimension and we got the dimension of the acceleration. L, t power minus 2. Is it clear? Okay, now you can practice by yourself to check the dimension of the force and the density by using their formulas. Okay, any question today? Not yet? Okay, so now please check the equation using the dimensional analysis. What is the formula? Yes, correct. This formula is the distance for the accelerated linear motion. Yeah, we can check the dimension in the left side and in the right side. And finally, we get the same dimension in both sides. It means the equation is dimensionally correct. Okay? Yeah, half year is ignored because it's just a constant. You know L plus L should be 2L, right? But 2 also ignored. Okay? T power minus 1 and T here are cancel each other. This is also cancel each other. Yeah. So you already understand about dimensional analysis. Okay, the material is finished. So any questions? Not yet. If any question, you can ask the question in the chat box or send me a message. All right, I will check your understanding again. Please scan this barcode to do the quizzes again. There are 5 questions and I will give you 5 minutes to finish them. Let's start. Okay, thank you for your participation. And for the next week, please read the material about factors and make a summary, okay? Okay, before we warm up, I want to make a summarize about this learning today. We already learned about physical quantities and the derived quantities, yeah, base quantities and derived quantities. And then we already learned about standard and non-standard measurement, scalars and vectors, and dimensional analysis. And this is the assignment for next week. Please read the material about factors from any sources and make a summary and submit it next week. And for tomorrow, I would like to remind you that we will have an offline class in the laboratory and we will measure a real object using a real vernier caliper. So don't forget to bring your lab coats. Enough for today. Thank you for your participation. I will stop share. Thank you again for your participation with this activity today and see you tomorrow. Bye bye.